Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 7.5, Proportions in Similar Triangles. By the end of the lesson, you will be able to use the triangle proportionality theorem and its converse. One of the words we're going to be using today is midsegment. And a midsegment is a segment that connects the midpoints of the sides of a triangle. So we're going to draw a picture to make sure that you understand what this is, because we're going to be using this in just a little bit. So you have a triangle. Here's a triangle. And you're going to connect the midpoints of the sides. So you got to find the middle of one side. I'll mark that's the middle. And find the middle of the other side. And connect them. I just connected the midpoints. So that right there is the mid segment. And we're going to talk more about that in a little bit. First, we're going to talk about the triangle proportionality theorem. This says if a line parallel to one side of a triangle, so here's a line that's parallel to this side, intersects the other two sides, it divides the two sides proportionally. Alright, so this side is cut proportional to this side. So RT to TQ is the same as RU over US. We're going to do some examples to make sure you really understand that. So notice we've got parallel lines. We need that first. So if these lines are parallel, then it cuts the sides proportionally. So we can write a proportion. So one example could say x is to 12. X is to 12 as 4 is to 8. Notice we're always working on the outside of these triangles. That's an important note to make, because we're going to talk about that in a second. And then you solve this. So if we write it out like they have, CD is to DB as CE is to EA. Now we're going to substitute, and this is like the equation we just wrote. X is to 12 as 4 is to 8. Cross multiply. 8x equals 48. Divide by 8. X equals 6. So we divided that by 8. All right. So because the lines were parallel, we got to write a proportion. Let's take a look at this example. Okay. So we've got parallel lines again. So we can write a proportion between the sides. But this one looks a little bit different. And we're going to do this to the side. Let's not worry about this. Let's do it over here. So I'm going to start with y is to 20. Y is to 20 as, y is to 20 as what? Well, what is y in the same spot as? Y is in the same spot as the 3. But what is 20 is the whole thing. So we need to use the whole thing over here. And this whole thing is 12. How did I get 12? I did 9 plus 3. So y is to 20 as 3 is to 12. Cross multiply. 12y equals 60. Y equals 5. In the follow-up, the question says, what is TS? Well, if y is 5, and here's TS, well, the whole thing is 20. We already have 5. That must mean TS is 15. Here's the converse, which flips it around. If a line divides two sides proportionally, then it's parallel to the third side. So if we see that these are cut proportionally, we know that TU is going to be parallel to QS. So let's take a look at an example of that. Determine whether MN is parallel to GH. Okay, these are parallel if these ratios are the same. So basically they're asking, are the ratios the same? Are the sides cut proportionally? Are the ratios equal? Okay, well let's check. Let's do this up here first. We're going to do LM over MG, LM over MG, and then we're going to do LN over NH. All right, so we're going to check this proportion, this ratio, and then this ratio. So LM is 56, 56 over 21. And if you remember, I taught you how to do this on your calculator. You put it in. I already know that 7 goes into both of those, right? But if you need to, you can use your calculator. Divide by 7, 8 over 3. Right? If you need your calculator, you do 56 divided by 21, math, enter, enter. Check that out. 8 over 3. Over here we've got 48 over 16. Well, what goes into 48 and 16? Well, I think that is just 3 to 1. Are these ratios equal? No, they're not. So that means the lines are not parallel. All right, because 8 over 3 does not equal 3 over 1, MN is not parallel to GH. All right, you're going to work on the checkpoints. This is like, let's see here. This is like example 1. This is like example 2. This is like example 3. And this is like example 3. All right, so you're going to do this now. You're going to write a proportion and solve. Down here, you need to also do this now. You need to check the ratios to see if it's parallel or not. And here's where we get to mid-segment, which is what I was talking about. Notice, here's a midpoint, and here's a midpoint, and it's connecting the two midpoints. This is the mid-segment. So the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. Because it's right in the middle, it's half of the side that it's parallel to. So DE is parallel to AB, and DE is half of AB. All right, so let's see if we can apply that. And we're going to do an activity that kind of shows this too. We're going to skip this. Given the diagram, find the length of QS. Well, look at, we're connecting midpoint to midpoint. See how it's right in the middle? The tick marks show that. If you're connecting midpoint to midpoint, you know that the length, this length, is half of this length. S is the middle of RT. Q is the middle of RP. So we see a mid-segment, and that's how we know it's half. QS is half of PT, which is half of 10, which is 5. You don't need to write all this out to know that this is 5. And notice we're working here on the inside of the triangle now. Before we were doing everything out here. Now we're working toward the inside segments. All right, so we've got midpoint to midpoint, midpoint to midpoint. So this is half, this is half. So you need to find P, you need to find Q. I want you to do this now. This is like example 4. This is M Cubed signing out.